swap markets and contracts. We'll generally follow the sequence in the curriculum, but as you have seen in the last few readings, a lot of material has simply been taken from level 1. So in this reading, the introduction, the structure, types of swaps comes from level 1, and I'm sure you are used to this. What do you think the focus is going to be in this reading? Pricing and valuation of swaps. In level 1, you basically learned what is a swap. Now we will learn how to price it and how to value it. So that will be the focus of this segment. Then in the next segment, we will talk about these other items which are, so there isn't too much detail in these. The key is, and the most testable area is section 4, pricing and valuation of swaps. Let's first do a quick recap of swaps. So this would serve as a quick summary of what you studied at level 1. The most basic kind of swap and the one that is used most often is a plain vanilla interest rate swap. A plain vanilla interest rate swap is simply a swap of cash flows. Typically you have two parties, so you might call them counterparty A and counterparty B. Both of them agree on some notional principal of say $100 million. Counterparty A is then going to make fixed rate payments. So based on the pricing and valuation that we discuss, let's say that over 3 years, counterparty A makes a 10% payment fixed at the end of every year, whereas counterparty B makes a floating payment based on some benchmark. That benchmark could be CIBOR or LIBOR or Euribor. So depending on the environment, the counterparty B, which is called the floating rate pair, is making a floating rate payment. Okay, so you studied this at level 1. This is your plain vanilla interest rate swap. A currency swap is one where you might have two currencies involved. So one party might borrow dollars, the other party might borrow euro, and both parties are making payments to each other in the currency that they borrowed. So we will see details of this later. And equity swap is where one party receives the return on some equity or some index while the other party makes interest rate payments. So in the next few minutes, we are going to study the pricing and valuation of these kinds of options in some detail. And a lot of people get confused by this, but as I have said before, all this boils down to time value of money. So if you pay attention and just focus on the core underlying concept, it's all time value of money. Okay. So section 4 is the main section, pricing and valuation of swaps. Before we actually go into the details of pricing and valuation, we need to cover section 4.1, which is an important learning objective, and this talks about the equivalence of swaps and other instruments. The two instruments that are mentioned in the learning objectives are forward contracts and options. So what is the equivalence between swaps and forward contracts? You've seen this in level 1. I will just make a statement and then explain it. An interest rate swap is equivalent to a series of off-market FRAs. So what does this mean? First, let's do a quick refresher on a forward rate agreement, and then what do we mean by a series of forward rate agreements. So if we are sitting here at time 0, a forward rate agreement would mean that we are getting into an agreement to borrow some money at some point in the future. Let's call it time 1, and so we are getting into an agreement at time 0 to borrow money in the future. So borrow money may be at time 1 for this period. Where does the forward contract expire? It expires when the underlying loan begins. So this might be one forward contract, and at time 0 we might get into a contract to borrow money at 5%. So this would be a FRA price. So this is, let's call this FRA 1. Now we might get into another forward contract also to borrow money at period 2 to be returned at, so borrow here, end of time 2, to be returned at end of time 3. So this is another FRA. Let's call this FRA 2 and so on. So I'll just do one more. So we might also have a FRA 3, which is borrowing for this period. FRA 3 expires, this is FRA 3, this might expire, this FRA expires over here. Now this is, and just for simplicity, imagine that we have a upward sloping yield curve. So the term structure of interest rates is going up, which would mean that the interest rates are progressively increasing for these forward contracts that are going further into the future. So I could create 3 separate contracts with my financial institution. So each of these is a separate forward rate agreement. Or I could essentially take these 3 and think of them and essentially create a swap, where in a swap I am saying that I am going to combine these 3 and I just have one contract where for each one of these periods I pay a certain fixed rate of approximately 6%, which is a rough average of these 3 rates. So I can say to the financial institution that, look, I want to borrow money and the fixed rate that I'll pay for this period and this period and this period is 6% per period. The advantage of doing this is, rather than doing 3 separate legal contracts and paying legal fee 3 times, I can just create one swap agreement where the matter is simpler. And actually swaps and interest rate swaps in particular are way more common than forward rate agreements. So do you notice, at least simplistically, how the swap is simply a series of forward rate agreements? Now if you are reading this statement carefully, you will wonder what this off market means. How many people wondered that? Okay, so maybe now is a good time to wonder. Alright, so off market means that the average, the swap rate that we will pick, the fixed rate, 6%, notice that this is different from the 5% and it's different from the 7%. The point is, when you have a series of forward rate agreements, you will have certain rates, which are the forward price. When you come up with a fixed swap rate, chances are that that fixed rate will be different from the market rates on the forward rate agreements. Why? Because this rate is going to be some form of a blended average of what we have. So when we say equivalent to a series of off-market FRAs, that means that this series of 6%, that 6% is not going to be the same rate as the market rate on forward rate agreements. So that's all that this off-market means. Okay, so that is the core similarity or equivalence between interest rate swaps and forward rate agreements. I'm not sure whether you really need to remember this from level 1, but very simplistically, with forward rate agreements, do you recall where settlement happens? The settlement happens where the FRA expires, whereas for an interest rate swap, each settlement typically happens at the end of the period. Okay. So anyway, there are a few other subtleties, but they are not mentioned in the learning objective, so I'll skip them. So memorize this statement. The next is the similarity between swaps and options. So what do you think we need to do here? Swaps and options. How are swaps and options? How can they be similar? Again, recall from level 1 that a forward rate agreement is equivalent to a long call plus a short put. How many people remember this? So a forward rate agreement is equivalent to a long call. This is a long call on what? This is taking a long position on a interest rate, going long on an interest rate plus going short on a put option. So I'll just refresh your memory on this. Let's say that you have a FRA with a rate of 5%. Okay, and we draw a payoff diagram, and the x-axis is rate. So if you've gone long on a FRA where the rate is 5%, are you in the money if the underlying rate is 6%? You are. Why is that good for you? So if the underlying turns out to be 6%, you benefit. Why? Because this gives you, because you are now borrowing at 5% even if the market rate is 6%. So the higher the market rate, the better for you. FRAs are obligations no matter what happens. So what if the market rate is 4%? Is that good or bad for you? That's bad, because now you still have to borrow at 5% even if the market rate is 4%. Okay, so this is the payoff for a long forward rate agreement. Now, what about a long call on, what's the underlying here? The underlying is interest rate with what strike price? 5%. So let me just do this in blue. So X is equal to 5%. You are long on this, taken a long position. So if the interest rate in the market is 6%, do you benefit? So if the interest rate in the market is 6%, you benefit. The higher the interest rate in the market, the more the benefit. What if the market rate is less than 5%? What's the payoff on the call? 0. Okay, so this blue, so this is the payoff on the long call. I'll also do the short put in blue. What is a put option? A put option, if you are long a put, when do you make money? You make money when the underlying is low. So in dots I'll put, this is the payoff on a long put. So if interest rates go down, the long put makes money. But we have a short put. So the short would be the mirror image of the long. So the short put would look like this. So notice if you add up the two blues, what do you get? You get the same as the red, which was your long FRA. So in essence, going long on your forward rate agreement is the same as being long a call and short a put. So taking this one step further, we've already said that a swap is equivalent to a series of FRAs, and then an FRA is, each FRA is equal to a long call or a short put. So for some strange reason, if you must do this, you can construct a swap by having a series of long calls and short puts. Okay, so that's just demonstrating the equivalence of a swap with options. Okay, so now we are going to get into the meat of this section, which is pricing and valuation. And we'll understand this through an example. Consider a 1-year interest rate swap with semi-annual payments. Determine the fixed rate on the swap and express it in annualized terms. The term structure of LIBOR is given here. So first point is, we keep, for every sort of derivative that we've talked about so far, we've distinguished between price and value. So when we talked about a forward or we talked about a future, so we talked about what price meant in that context. In the context of a swap, what's the price of a swap? The price of a swap is the rate that is paid by the fixed rate pair. Okay, can you say that? The price of a swap is the rate that is paid by the fixed rate pair. So when we price a swap, what do we need to do? Figure out what the fixed rate pair must pay. And clearly what the fixed rate pair must pay must depend on the term structure of interest rates. So if you have a real simple situation, we are asked to find the fixed rate on a swap, express it in annualized terms, that always needs to be done, and you are given this term structure. Okay, so the swap price is the fixed rate. So how do you come up with the price? Did you do this in level 1? You did not. In level 1, the price was just given to you and you used it. So now that you are bigger, you need to be able to come up with the price. How do we do this? The principle that we will use is that the present value of fixed payments must be equal to the present value of floating payments. Okay, so using this principle, we will come up with the price of a swap, and we will use a notional principle of $1. Okay, so now let's start with if you have a notional principle of $1 and these are the interest rates, what is the present value? Okay, so let's do this. Let's say that you are given these interest rates. So you are looking at how much a fixed rate payer must pay. What do we have as a swap? It's a 1-year swap with semi-annual payments. So you have your 1-year swap, this is times 0. Semi-annual payments means one payment after 180 days and then 360 days. So let's say that your fixed payment is your coupon payment, which is C. Okay, we are figuring out how much payment you need to make. So you need to make C and C. This is in dollars. And given that the notional principal is $1, you also pay the $1 back at maturity. So what is the present value of these payments? What's the present value of this? So for a payment that happens after 180 days, how do you figure out the present value of that? So what's the rate? It is 7.2% on a annualized basis. So what you need to, the technique used is that you come up with present value factors. And I'm actually going to use the terminology in Schweser because I think that is considerably easier than the terminology in the curriculum, even though I'll briefly explain the curriculum terminology, but I'm using the curriculum example because I think it's better, and Schweser terminology because I think that's better. So overall you need to understand what to do. So if this is 7.2%, what's the present value factor? We will call that present value factor for the first payment, we'll call it Z1. So what is Z1? Z1, the factor, is 1 over 1 plus 0.072 into 180 over 360, since this is half a year, so over 2. So what does this come out to be? Okay, so this should be 0.9653. Alright, so that's the present value factor Z1 for this payment. Then you come up with the second present value factor. So for a dollar received over here, Z2 represents the present value for any money that you receive at the end of 2 periods. Each period is 180 days. So what would that be? That would be 1 over 1 plus what? 0.08. So that is equal to 0.9259. Okay, so you understand this is Z1, this is Z2. So what then is the present value of these payments? Can you tell me the present value for all these payments? What are the 3 payments? It's the C, and the $1. So the present value of the fixed is how much of this fixed coupon? The present value is C. So it is C and then multiplied by the present value factor. So C into this plus C into that. So I'm actually going to write it out because this creates confusion. 0.9653, which is the present value factor for this one, into C plus this second C, and what's the present value factor for this C? 0.9259 C plus what? Plus the present value of that $1, which is 0.9259. So what does this represent, this expression? The present value for the fixed payments. Now we need to equate, so that is this part, to determine the fixed rate. So we need to determine the fixed rate which will make the present value of fixed payments equal to present value of floating payments. So what have we done? We've done this part. This is the present value of fixed payments. What do we need to do next? At time 0, what is the present value of floating payments? Now you might recall this from level 1 if you are really, really smart. Okay, can somebody figure out what is the present value of the floating payments? The present value of floating payments is 1. And that is because, if you recall, for a floating rate security, at reset date, the value of a floating rate security resets to par value. Okay, so the point is, with a floating rate security, do we know what the next coupon payment will be? We do. Why? Because for a floating rate security, the next coupon payment is based on the interest rate over here. But do we know what the payment will be over here? The next payment. We don't know the next payment because that payment is going to be on this rate. But what we do know is that after one period, if the rate is high, then the coupon payment, the cash flow will also be high. So the discount rate will be high, but the cash flow will also be high. The net impact at time 0, and in fact at any reset date, the value of a floating rate security is equal to par value. Can you memorize the statement? So the present value of a floater is equal to par on reset dates. The exception is if you are talking about a bond that has credit risk, and if the credit risk changes, but that is not something we will get into over here. Is this obvious to everyone now? So then we have an expression for the present value of fixed payments. We have the present value. So what's the present value of floating rate payments? 1. So instead of this, so what can I write over here? 1. So notice 1 is equal to this. So based on this, can I calculate C? Okay, and now I'm going to help you remember the formula for this. So note, what was this thing over here? I'm just going to change back to red and point out something. This C is the coupon. What was 0.9653 in terms of our symbol? That was Z1. What was 0.9259? This was Z2. And what was this is also Z2. So I know that algebraically you can easily solve for C, that would be your fixed payment. But how would we come up with a generalized formula? Notice that we have 1 plus Z1, so this is Z1C plus Z2C. So you can write Z1 plus Z2 times C plus, actually I should say 1 is equal to, right, that 1 is equal to Z1 plus Z2 in brackets times C plus Z2. Now if you solve for C, what is C equal to? C is equal to 1 minus, what was Z2? It was this discount factor for the second payment, divided by Z1 plus Z2. So this is the formula that we just derived for what? For the fixed payment every 180 days in this example. Can you memorize this? I'm actually going to write it again on the next slide. So if you have a payment every 180 days, then the fixed coupon payment, and this would be plus the $1 par, the fixed coupon payment is equal to 1 minus Z2 over Z1 plus Z2. Okay, so this is the formula. Now, to generalize this even further, is it possible that you have a bond that has quarterly payments? That's what Schwezer does. So, in the Schwezer example, you will have quarterly payments like this, 270 and 360. So their Z1 is the discount factor for each quarter, and then the formula becomes what? It becomes 1 minus, so this is always the last discount factor divided by Z1 plus Z2 plus Z3 plus Z4. So can you memorize this formula? So actually I would say you memorize this, and then based on this you can then just know what else will come. Since this is there in the curriculum example, I think you are more likely to be tested on this simplistic version because it demonstrates that you know this material. Okay, so this is the formula for coming up with C. Is C an annualized number or a 6-monthly number? So if you are coming up with a C over here and then to annualize it, what would you do? Double it. If you are doing a Schwezer example where you have quarterly stuff and you come up with C, then what will you do? Multiply it by 4. Okay, so make sure you know this. Okay, so what did we just, actually let's just finish off this this example over here. So this was the formula. So what is the value of C? If you actually do the calculation, yeah, you get 0.0392. So the Z is equal to 0.0392. So what then is the fixed rate or the price? So the fixed rate or the price, is it this number or this times 2? It is, so the price or the fixed rate is equal to 0.0392 multiplied by 2, which is, so this will effectively come out to be 7.84%. So 0.0784, which is 7.84%. So what does this represent? This is the price of the swap. It's the rate that the fixed rate pair needs to pay. Now what do you think you'll have to do next? Next is 90 days later, interest rates change. When interest rates change, what's the value of a swap? So determine the market value of the swap from the perspective of the party paying the floating rate and receiving the fixed rate. Assume a notional principal of 15 million. The way we will do this is basically what the curriculum does, which is start with a $1 notional principal and then simply multiply by 15 million at the end. Now, what is the perspective that we need to take? The party paying the floating and receiving fixed. So the swap value, since what is he receiving? He's receiving the fixed. So think of the receiving the fixed as his revenue. That's the money coming in. So the present value of the fixed payments, that's the money in. And what's his cost? This guy is making floating payments. So minus the present value of the floating payments, you subtract that, that's the cost. So we'll do this for $1 notional principal and then multiply by the actual notional principal, which is 15 million. So what's happened now? We are 90 days later and these are the rates. So let's just draw this out. So this was our original picture, 0, 180, 360. Now we are here at 90, and very conveniently we have been given the 90-day rate. So this is 90 days. So we are given this rate, which is 7.1%, and given that we are here, we are also given the 270-day rate, which is from here to here is 270 days. That is 7.4%. Okay, so the swap value is the present value of fixed payments. Do we know what our fixed payments were? Our fixed payments are C and 1 plus C. Do we know what C is from our previous calculation? What was C? No, C 7 point something was the annual. The C here is the actual payment that you need to make. Okay, so 0.0392, and this would be 1.0392. So can you find the present value of these payments? Do you use the same discount factors from before, or do you need to come up with new discount factors? What's the discount factor for this 90-day period? It would be 1 over 1 plus what? It's the 90-day rate, 0.071 multiplied by what? 90 over 360, or simply divided by 4. So it would be this discount factor multiplied by C. And what would you multiply this by? What's the discount factor here? So it would be 1 over 1 plus, what's the rate here? 0.074 into, this is coming back 270 days. So into 270 over 360. So this and this together will give you the present value of fixed payments. So this is in red. Now, what is the present value of floating payments? Let's do this in blue. So the present value of floating payments. How do you do this? You are here at this point. Do you know, if you are the floating rate payer, then do you know this payment? How? What was this payment based on? When was this payment established? The amount. This payment was established based on the floating rate at time 0, which was what? So floating rate at time 0 was 7.2%. Right? So the rate here was 7.2%. So based on that floating rate at time 0, what's the payment, the interest payment that the floating rate payer has to make? How would you figure that out? So that would be half of this, since it's half of this, so it would be 0.072 divided by 2, right? That's the payment that needs to be made here. Is everybody with me? Okay. Plus, do we know what payment the floating rate payer will make over here? We don't, because we don't know what this rate is going to be. But what we do know is that the value of the bond on reset date will be par. So that par value represents the present value of future cash flows, which in this case is just one future cash flow, but it could have been 100 future cash flows. So you simply add plus 1 over here. This plus 1 represents all future cash flows on the floating rate security. Again, just say this to yourself 100 times if you are confused, that at reset date, the value of a floater will be equal to par. Okay, so from a floating rate perspective, at this point, the cash flow will be 1 plus this. So what do you do? How do you come up with the value of the floating rate payment at this point? You simply take 1 plus this and you discount back to this point. How do you discount back? You take this and multiply by what discount factor? The same discount factor that you calculated earlier. So you take this and you discount back using this factor, and you have this number over here. This number over here represents what? The present value of floating payments. So when you do the math, what will you end up with? Okay, I'm just going to write the numbers here. The present value of the floating payments, the answer you should get for this blue number is 1.0180. So this is 1.0180. The present value of the fixed payments, which I will go back to red, the present value of the fixed payments should be 1.0231. Okay, so what is the swap value? The swap value is the difference of this and this, which is, the difference of these two is 0.0051. So this is the swap value for this position on $1 notional principal. And how do we wrap this up? Since our notional principal is 15 million, we take this and multiply it by 15 million, and what you should come up with is 76,500. So this is the value of the swap on day 90. And clearly it depends on how interest rates have changed. Make sense or not? Okay.